3-3 Dividing Polynomials, Remainder and Factor Theorems, Day 3. Our learning goal is that you will be able to evaluate a polynomial using the remainder theorem and use the factor theorem to solve a polynomial equation. According to the remainder theorem, if a polynomial is divided by x minus c, so let's say we have this polynomial and we divide it by x minus c, then the remainder is the same thing as f of c. That means if you plugged in that value, you'll get the remainder. So for example 1, we're going to use synthetic division. Basically what that means is if you have this polynomial, x cubed minus 4x squared plus 5x plus 3, and you were dividing it by x minus 2, your remainder is the same thing as you just plugging in 2 for all the x's. But instead of us doing that, plugging in 2 for every x, we're going to use synthetic division. So remember with synthetic, you would take the x minus 2, set it equal to 0. X would be 2, and that would be your divisor. And remember, you check to see if any terms are missing. And if they're not, then you write the coefficients: 1, -4, 5, and 3. Remember, the process involves you bringing down the first term. 2 times 1 is 2, add going down. 2 times -2 is -4, add going down. 2 times 1 is 2, add going down. Remember, this last term is your remainder. So the way that you write your answer is f of 2 equals 5. So that's how you use synthetic division and the remainder theorem to find the indicated value. The factor theorem. According to the factor theorem, when you have a polynomial, you're still going to use synthetic division. And let's just say we have this polynomial f of x. And remember that last example, what we did, in order for this to be the factor theorem, your remainder has to be 0. So when you do synthetic and you divide by x minus c, that means that f of c, that number that you're using to divide by, the remainder has to be 0 in order for it to be a factor. And that's just like if you did 12 divided by 4, the answer would be 3, remainder of 0. So that's what the factor theorem means. So if that is true, then that means that x minus c is a factor. So if the remainder is 0, x minus c is a factor. So we're going to use example 2. We're going to use synthetic division to divide 2x cubed minus 3x squared minus 11x plus 6. And we're going to divide that by x minus 3. So I'm going to set that equal to 0. Oh, and then we're going to use the result to find all the zeros. So 3 is my divisor. I don't have any terms missing, so I'm going to use 2, -3, -11, and 6. All right. So we start our process. Bring down the 2. 3 times 2 is 6. Add going down. 3 times 3 is 9. Add going down. 3 times -2 is -6. Add going down. This is what you want to happen. You want to have a remainder of 0. because that's what the factor theorem means, that x minus 3 is a factor. So then you're going to take your coefficients and write it back. So this would be 2x squared, because remember we lose a degree, plus 3x minus 2. And we already had the x minus 3 from the beginning, because that's what they gave us. And all of that is going to equal 0. So what you're going to do is factor this part in blue. And remember, you get to factor any way you like, whatever method you use. I do find two numbers and multiply to give you -4, to add to give you 3. So that would be positive 4 and minus 1. And I divide them both by 2 because that's your leading coefficient. So then we get x plus 2 because that divides evenly. And this 2 goes in front of the x. That's 2x minus 1 equals 0. So when it says find all zeros, you're going to set each one equal to 0. So we have x minus 3 equals 0, or x plus 2 equals 0, or 2x minus 1 equals 0. Sorry about that. So my zeros are 3, x equals -2, and x equals positive 1/2. And you may see them write it like this in set notation. And that's your answers, or those are all of your zeros. But when we write it and they say find the zeros, we write it like this: 3, 0, -2, 0, and 1/2, 0. So that's the correct way to write it when they say find all zeros. Example 3, we're going to solve the equation given that -1/3 is a root. When you see the word root means the same thing as solution or 0. So basically what that means is you're going to use -1/3 as your divisor. So just to note, they're not always integers. They could be fractions. I don't have any terms missing, so I'm going to do 3, 7, -22, and -8. Now, if they're saying that this is a root, that means that your remainder should be 0. If it's not, you did something wrong. Okay, starting the process. -1/3 of 3 is -1, add going down. -1/3 of 6 is -2, add going down. -1/3 of -24 is 8, remainder 0. That's what you want. And then what you're going to do is write this back as a polynomial. And you would factor. But before I factor, I noticed that all of these have a 3 in common, so I'm going to take out a 3. And then I'll factor this. Then I set each one equal to 0. Each factor when I'm solving for x. So I don't need to set the 3 equal to 0. So x equals -4 or x equals 2. So my solutions are, and they already told me that -1/3 was a root. So -1/3, -4, and then we have 2. So just to let you know, your degree indicates how many roots or solutions you'll have. So that's very important. The degree equals the number of solutions or roots or zeros.